All right, so last time we dove into supervised learning, which is where you give a machine labeled data. You basically give it an answer key. But what happens when you don't have an answer key? Well, that's what we're talking about today. We're jumping into the really cool world of unsupervised learning, where the models have to figure it all out on their own.
Yeah, it's a really good question, right? If you don't tell the machine what the correct answer is, how in the world could it learn anything useful at all? It kind of feels impossible, but that's the exact problem that unsupervised learning was built to solve.
So the whole game really boils down to this one simple difference. Supervised learning needs those labels. This is a cat, this is a dog. Unsupervised learning, on the other hand, gets handed this giant, messy box of data with 0 labels and is just told, go find something interesting in there.
Okay, so that's the formal definition. But check out the big shift in thinking here. Without labels, the goal isn't really accuracy anymore. The model can't be right or wrong. Instead, its job becomes more like a detective's. Its mission is to uncover the secret structure, the hidden patterns, and all the juicy features that are already hiding inside the data itself.
Okay, enough with the theory for a second. Let's see how this actually works. Our first stop is one of the most common and honestly one of the most intuitive types of unsupervised learning, clustering.
So let's imagine a classic scenario. We've got this huge spreadsheet with 2 columns, a person's height and their weight. But, and this is the important part, that's all we have. We don't know their gender, we don't know their age, nothing. Just raw, unlabeled numbers. The data looks something like this. Now, to the algorithm, these aren't people, they're just pairs of numbers. You can think of them as a collection of dots on a graph. Without any labels to guide it, what is it even supposed to do with this? And this is where the magic starts to happen. The algorithm gets to work. It starts plotting all these points and just starts looking for natural groupings. It's not looking for men or women. It doesn't even know those words exist. It's just looking for dots that seem to be close to each other, the ones that are kind of hanging out together.
And boom, this is what you get. The algorithm, completely on its own, finds these separate little clumps, these clusters in the data. In our example, it probably finds 2 main groups. It's only after the machine does the hard work that we, the humans, step back in. We can look at the clusters, see one group of taller, heavier people and another of shorter, lighter people, and we can infer what it found. It probably separated the data by gender, all without ever being told what to look for. Pretty amazing.
Okay, so that's clustering. It's all about finding groups. But what if the patterns are way more subtle than that? Let's move on to our second example, which is, well, it's a little more mind-bending, but it's incredibly powerful. Let's talk about autoencoders.
I know what you're probably thinking right now. This sounds strange. Why in the world would you build a complex program just to create a copy of a picture or a piece of data that you already have? It seems totally pointless, right? But trust me, the real power isn't in the copy itself.
So what is an autoencoder? Simply put, it's a type of neural network that's trained to do one single thing: make its output look exactly like its input. You give it a picture, it does some processing, and it tries to spit out a perfect copy of that same picture. Now, the really clever bit is what happens in the middle. Look at step 2, encode. The network is forced to squish the image down through this tiny bottleneck, compressing it down to only its most essential features. It's kind of like trying to write a one-sentence summary of a whole movie. Then, in step 3, it has to take that tiny summary and try to rebuild the original image. That whole process of compressing and then reconstructing forces the network to learn what's really important about the image. Which of course brings us back to our main question. If there aren't any labels, how does this network even know if it's doing well? How can it judge its own work?
Well, the answer is this really smart idea called a loss function. You can think of it like the model's own built-in critic. The function just compares the copy to the original pixel by pixel, and it calculates a penalty score based on how different they are. The more different they are, the higher the score. And the network's only goal in life is to keep tweaking itself over thousands of tries to get that loss score as close to 0 as it possibly can. And here it is. This is the big reveal. We don't actually care that much about the final copy. The real treasure, the whole point of the exercise, is in that compressed summary it created. By learning how to perfectly reconstruct an image, the model was forced to understand the absolute essence of that image.
And this leads to some incredible applications, like denoising images. See, because a trained autoencoder knows the core features of, let's say, a handwritten number 7, it has this internal concept of sevenness.
So if you give it a picture of a 7 that's covered in random static and noise, it recognizes the essential pattern of the 7 and just ignores all the noise. Then it reconstructs a brand new, clean version, because the static was never part of the essential features it was forced to learn in the first place.
Okay, so let's zoom out and tie all this together. What's the big picture? What's the main thing you should take away from all this?
At its heart, unsupervised learning is just a master at finding hidden structures. It does this in a couple of different ways, either by grouping similar things together, like we saw with clustering, or by learning to pull out and rebuild the most essential features of the data, like we saw with autoencoders.
You know, this quote really just says it all perfectly. The whole point is to give a model this black box full of messy data and have it come back to us with the blueprint, the underlying structure, the key features, the useful information that we might have never been able to see on our own.
And that leaves us with one last really exciting thought. In a world that is creating more unlabeled data every single second, unsupervised learning is like a powerful new pair of glasses. It's looking at everything from customer habits to images from space, and it's finding patterns we never even knew were there. The real question is, what will it discover next?